briefly introduce the fourth course of this sequence, part 4, renewable energy and storage. This course will be taught by me and Professor Kaushal Jha together. I will do one part, other part will be done by Professor Kaushal Jha. The course has 3 chapters. So, in sequence, if 1, 2, 3 was course 1, 4, 5 was course 2, 6, 7 was course 3, this should be course chapters 8, 9 and 10. In the first one, we will do an introduction to energy scenario in India and solar PV. What does it take for India to get to 100% renewable energy? And we will go beyond solar, wind, lithium ion and chilled water storage. We will discuss this. And then we will get into solar and wind energy in India, solar photovoltaics, solar cell and its characteristics, solar cells to modules, wind energy, war of currents, birth of solar DC. We will also get into next storage options for energy, grid storage, energy storage systems and its needs, services of energy storage technology, mechanical, chemical, electrical and thermal energy storage systems. In the part energy scenario in India of the 4th course, first module, increasing use of fossil fuels have become the primary cause of global warming. India usage is dominated by fossil fuels. India ranks 103rd in terms of per capita electricity consumption, and therefore, it is polluting very low, 140th in terms of per capita carbon dioxide emission. But that is only per capita. If we talk about GHG emission, we are total GHG emission, we are probably 3rd, not 2nd. I think this is a mistake. 3rd in terms of GHG emission. But soon we can get to 2nd and we have to worry about it. So, India needs to act fast and push for renewable. Today, India is the largest photovoltaic power station. Other renewable energy sources should be explored, power storage must grow. We will not just talk about technology, but once again talk about economics in Indian context. Cost of usage per kilowatt hour of grid storage, storage plays an important role, impact of cell type and depreciation, interest rate on cost per kilowatt hour. Total cost of renewable energy per kilowatt hour in India, cost of wheeled renewable energy plus storage. We will talk about decentralized storage can be used to meet short term required for daily mismatch. Long term renewable energy and demand mismatch can be compensated by technology like pumped hydro, compressed air, hydrogen storage. We will give you a much better picture of that. To move towards 100% renewable energy, we must go beyond solar, wind, lithium ion and chilled water storage, and we have to explore hydrogen, redox flow battery, zinc, polyiodide, metal air flow battery, and we have to look at hydrogen, and we will get into all these details to some extent. Going forward, India would require expand renewable energy sources, going beyond solar and wind, and tap if possible nuclear and ocean energy. For power distribution and energy generation, we have to do wheeling of renewable energy, grid, we have to talk about high voltage DC grid, we have to talk about all kinds of storage, battery, flow battery, chilled water, hydrogen, pumped hydrogen. Electric vehicles will play an important role, battery and hydrogen powered, enhanced energy efficiency in air conditioning, because if we use a lot of energy in air conditioning, it will impact our GHG emission. Industry usage, use of heat pumps, hydrogen and decarbonization. Agriculture, solar pumps and electric tractors. Construction, use of electric power equipment, policy intervention, metering, speed and economic viability, power management. We will then get into details of solar and wind energy in India. History of PV dates back to 1839. We will get into how solar photovoltaic was invented. We will get into solar cells in detail and how does solar cells produce DC power and we convert it to AC power. We will get into that solar cell is basically a PN junction, important parameters of solar cells, and then PV cells can be connected in series to get desired voltage and in parallel to get desired current. We will talk about when you install solar, we have to worry about shading effect, temperature, non-identical cells, angle of incidence, cable losses, DC to AC conversion, all these things we will get into. And we will then compute cost per unit electricity, per unit energy for solar energy. And we will discuss how India is blessed with vast solar energy and decentralized solar panel at rooftop can be an effective solution. We will then get into wind. Wind turbine can generate at most 59% of power of wind in kinetic energy. So, 59% can be converted. And we will talk about how do you maximize that. Rotor blades, shaft generator, bigger rotor, higher hub height, annual wind generation in India, spacing of turbines in a wind farm, depends on terrain, wind direction, speed and turbine size, looking at wind energy potential in India and capital cost of wind power plants versus fossil fuel power plants. We will then get into something very interesting, DC versus AC. Should we use DC power or AC power? This debate dates back to 1880s between Thomas Edison and Nicholas Tesla. We will get into that and talk about why DC to some extent is viable and maybe time has come to convert to DC, and we will talk about particularly in a decentralization mode how DC can be effectively used. So, we will talk about birth of solar DC and how solar DC was used, something that was developed at IIT Madras very widely to deployed in specifically in those places where there is no grid and how it helped a lot. We will get into storage options, because without storage renewable energy cannot be used. Renewable energy is not available 24/7. It is not cannot be controlled by human being. Sun shines when sun shines. Wind is there when wind is there. We need to store it for using when we need it. And we will get into different kind of energy storage technology and how to match the generation, the load and the storage. We will talk about mechanical storage, electrochemical storage, electrical storage, chemical and thermal storage. This is what we will do in the fourth course, and we will get into details of lithium ion battery storage for grid energy and also on chilled water storage, a little bit on zinc air storage. This is what we will do in course number 4. In 16 weeks, you should be able to get a very good overview of electric vehicles as well as renewable energy. This is what we promised to do. It will be 4 independent courses, will follow one after another, and hope you are able to do all of them. Thank you very much.